Now every test we run has 5 steps, and each test, the second step is our hypothesis. Each hypothesis has both our assumption and what we're trying to prove in it. The first is what we call our null hypothesis, or pronounced H naught. Our null hypothesis is what we're going to assume is true. HA, what we call our alternative hypothesis, is what we're trying to prove. Now these are going to look really close to each other, and for a one proportion hypothesis test, the actual form they're going to take is H naught will be P equals blank, and HA will be P and blank. Now it's important to realize what P stands for, and so this is the population proportion. This is if we surveyed everyone, not just 100 or 1,000 or even 10,000 people, but everyone we possibly could. This is the percentage of them that would feel a certain way or have a certain characteristic. So that's why it's P, not P hat or anything. Now over in the blank here, we're going to go ahead and put whatever our assumed value is. That is, we'll put P naught over here. That's because we're going to assume P naught is accurate. So we write P equals P naught. The population is equal to this assumption we're making. That's the null hypothesis on top. For the alternative, we'll still put P naught over there, but we're not trying to prove that's equal. We're trying to prove maybe it's greater than, or it's less than, or later on it's not equal to. So for our null hypothesis, we have equal to, but for our alternative here, we write it slightly differently. That is, our alternative hypothesis will have P, and over on the side here we'll write whatever P naught is, and in between we can write either greater than, if we're trying to show it's greater, above, or more, or we can write less than, if we're trying to show it's under, less, or maybe fewer. Let's go ahead and look at an example of this in order to get a little bit more in depth into it. Let's say, for example, I want to run a hypothesis test, and I want to check, can we conclude that over 10% of all flights are late? Now, in order to understand why we're doing a hypothesis test on this, we need to assume, first of all, that I don't have access to all flights. And because I don't have access to data on every flight ever taken, I need to go ahead and take the data I already have and then make an inference about what would happen with every single flight. To do this, we do our first step with listing our information, and when we got to our second step here, we'd write down our hypothesis, H naught and HA. H naught, I write P equals, and HA will be P, and then I'll have two blanks I fill in. Now, when I run this hypothesis test here, I'm going to assume that whatever my assumption is of whatever P naught is a true value. So that is, because I'm trying to conclude that over 10% of all flights are late, I'm going to assume in the beginning that's actually exactly 10% of flights that are late. So that is, H naught will be P equals 0.10. That's what I'm going to assume, but not what I'm going to try and prove. I'm trying to prove that over 10% of all flights are late. So I'll go ahead and put the 0.10 there, and I'll put it greater than there, because I'm trying to show that, once again, it's over 10% of flights that are late. Let's go ahead and look at another example here. In order to do this, we're going to go ahead and move up a little bit. Let's say that I was trying to show, or trying to ask, can we conclude that under 5% of dogs like baths? In order to do this, I need to go ahead and realize, once again, I'm trying to conclude something, hypothesis test. I've got a percent in there, so it's a proportion, which means when I get to step 2 of my hypothesis, I'll write H naught and HA. H naught is always P equals, HA will be P, and then I'll fill in the rest. Now, I'm trying to show that under 5% of all dogs like baths, which means in the beginning, I'm going to assume it's exactly 5%. I'm assuming that so that then when I go down to my alternative hypothesis, I can show what I actually want to find. That is, I want to show that's under 5% of dogs. So I'm going to have P is less than. That's under 5%. So in summary here, whenever I go to set my second step for a hypothesis test for one proportion, I'm going to do so by writing H naught, that is my null hypothesis, and I'll write P, the proportion of everyone, is equal to my assumed value. Then I'll write HA, my alternative, what I'm trying to prove, with P is either greater than, less than, or later on we'll get not equal to, P naught, my assumed value.